Welcome to this explainer, where we're going to unpack the absolute definitive blueprint for launching and honestly mastering your career as a data engineer in 2026. Look, if you've been watching the literal mountain of data being generated by modern businesses and wondering, who actually builds the insane plumbing required to handle all of this? And more importantly, how do I become one of those people? Well, you are exactly in the right place. We're going to break down precisely what you need to know, what you need to learn, and what you absolutely must build to secure your spot in this incredibly high-demand field. So let's take a really quick look at our roadmap for today. We're covering 5 key areas. Number 1, the data engineer role itself. 2, the 2026 learning roadmap. 3, the certifications that are actually worth your time. 4, how to build the perfect portfolio. And finally, number 5, acing that technical interview. All right, let's jump right into part 1, the data engineer role, defining the destination. So think of a data engineer essentially as the architect. You're the one building the critical infrastructure that makes sure data flows cleanly and reliably across an entire organization. Right now, everybody loves to talk about artificial intelligence, real-time analytics, massive machine learning models, and sure, that stuff is flashy, but here's the reality check. Literally none of that happens without a data engineer laying the groundwork first. Think of it this way. If an AI model is a high-performance sports card, you're the one refining the fuel. You're designing those complex behind-the-scenes systems that pull info from dozens of different sources and making absolutely sure it doesn't just completely break when a million users log on at once. It really helps to think of it like this. Engineers build the resilient pipes, while the data scientists use that flowing water to pan for predictive gold. I see people confuse these roles way too often. A data scientist might be a wizard with advanced math and algorithms, but if they get handed a swamp of dirty, unstructured data, their models will absolutely tank. They rely entirely on you, the data engineer, to make sure the data they're looking at is accurate, clean, and accessible at a massive scale. You are the prerequisite to data science. Without your architecture, there's just nothing for them to analyze. Okay, moving right along to Section 2, the 2026 Learning Roadmap, Mapping the Route. What I really love about this roadmap from Analytics Vidya is how it takes a frankly overwhelming amount of technical information and structures it into a super intuitive progression. It doesn't just throw you into the deep end of complex distributed systems on day one, because honestly, that is exactly where most beginners completely burn out. Instead, it really emphasizes building a rock-solid programming foundation first, before slowly layering in those specialized tools you'll need to handle scale. And that step-by-step layering, that's how you build true engineering intuition, rather than just rotely memorizing a bunch of syntax. To keep you from getting cognitive overload, let's break this down into a chronological timeline. So in quarter 1, you're getting your hands dirty mastering Python, SQL, and relational databases. That is the absolute core of all data manipulation. You've got to know how to query data before you can move it around, right? Then, quarter 2 pushes you into the cloud with AWS or Google Cloud Platform and introduces Apache Spark for crunching massive batches of data in parallel. By quarter 3, things get really fun. You dive into big data warehousing and real-time streaming with Apache Kafka. And finally, quarter 4 ties the whole shebang together with NoSQL databases and workflow scheduling, using Apache Airflow, so your pipelines run automatically on schedule. By the end of this roadmap, you're going to master the fundamental ETL process. That's extract, transform, and load. This is the absolute bread and butter of data engineering. You're extracting messy, chaotic data from wild sources, like third-party APIs, transforming it into a pristine, standardized state, and then loading it into a central warehouse where the business can actually use it. Whether you're running a simple Python script or managing a massive distributed cloud architecture, designing and maintaining this 3-step pipeline is going to be your primary mission every single day. Let's pivot to Section 3, certifications worth your time, packing the right gear. Now, when you're choosing a certification, you have to keep one crucial rule in mind. It has to test your reasoning, not just your recognition. So many beginners fall into this trap of thinking that just collecting digital badges will magically get them hired. But listen, multiple choice questions rarely teach you how to debug an overflowing data pipeline at 2 a.m. You really want to go after certifications that expose the gaps in your systems-level thinking, rather than tests that just ask you to match a brand name to a definition. The easiest way to think about your options is dividing them between cloud and vendor certifications. Go for a cloud cert if your target company is heavily locked into AWS or GCP infrastructure, because understanding the unique quirks of a specific cloud ecosystem is a massive asset. But definitely look to vendor certs like Snowflake or Databricks if you need to prove you have deep analytics workflows. Like, if you want to build real-time streaming pipelines, nailing a specialized cert like Confluence Apache Kafka, that's going to prove your technical execution skills way better than a generic cloud badge ever could.
All right, Section 4, the perfect portfolio, proving your worth.
Why does a portfolio matter so much? Picture this. It's 10 p.m. An exhausted hiring manager is sifting through literally hundreds of resumes that all list the exact same technologies. Your GitHub link? That's your one shot to weak them up. It's the secret sauce that sets you apart, proving that you don't just know the latest buzzwords, but you can actually build the reliable systems they desperately need to keep their business running. A genuinely good portfolio stops them from skimming and forces them to pay attention.
And there's an unspoken checklist these managers are scoring you against. Bottom line, they want to see you tame the chaos of real-world data. They absolutely do not want to see another basic tutorial that uses perfectly formatted, squeaky clean toy data. Nope. They want to see you extract broken, incomplete data from a live API, handle the missing values gracefully, structure it properly, and, this is huge, document your decision-making process so clearly that anyone could understand it. They're looking for hard proof that you can handle the unpredictable nature of enterprise data.
If you only take away one single thing about portfolios today, let it be this: depth and completeness will beat quantity every time. One single, robust pipeline that runs automatically in the cloud, handles errors without completely crashing, and features a brilliantly written README detailing your architectural choices, that is worth way more than a dozen half-finished scripts. You have to show them you are truly ready for production. Let's tackle our final section, Section 5, acing the interview, the final boss. When you finally sit down for the technical interview, you are inevitably going to get hit with scenario-based questions just like this one. They are testing your architectural reasoning over your coding syntax. Look, they already know you can write a loop in Python. What they want to know is if you can choose the right tool for a multi-million-dollar job based on really specific business constraints. The key to answering this is explaining the why. You choose batch processing for your heavy, historical analytics, like crunching massive amounts of static data overnight for a monthly sales report. It's incredibly efficient for large volumes where time just isn't critical. But you pivot to stream processing when the business needs an instant reaction. If you're trying to detect a fraudulent credit card transaction before the swipe is even approved, batching is useless. You have to use stream processing to act on unbounded data with millisecond latency. Proving you get that business context is exactly how you ace the interview. Here's another classic interview hurdle: being asked to design a data model and actually defend your structural choices. You have to show them you understand how data organization fundamentally impacts both your storage costs and your query speed. So here is the core trade-off you need to articulate. Star schemas prioritize blazing fast query speed for analytics, while Snowflake schemas prioritize strict data integrity and saving storage space. With a star schema, everything revolves around a central fact table, which means fewer complex joins. Analysts can pull data super fast. The Snowflake schema, though, normalizes that data, breaking the dimensions down further to save space. But that forces the database to work a lot harder when it's stitching the data back together. Knowing exactly when to prioritize speed over space, that's the mark of a true engineer. Ultimately, passing an exam or nailing a textbook question is just day one. The technology in this field is absolutely going to change. Cloud platforms will roll out new services. Faster processing engines will pop up and replace the ones we're using right now. But the core principles, data reliability, fault tolerance, clear architectural communication, those will literally never go out of style. Consistent practice is the only way you build that lasting foundation. So, I want to leave you with this final challenge. Stop reading articles about data pipelines and go start building one. Grab a messy dataset, write the Python script, stand up the database, and just prove it to yourself. Are you going to keep watching from the sidelines, or are you ready to build the infrastructure of 2026? Thanks for joining me on this explainer, and hey, happy building.